Lastly, we talked about exponential functions and their laws and properties of exponents. Today we're going to be talking about logarithms. And we're going to look at their properties and their laws, and we're going to be able to use them to apply them, as well as find inverses to exponential and log functions. Okay, that's all what we're doing today. You guys have the whiteboards because we are going to be practicing as well to make sure that this topic is engraved. Okay. And we're going to start off with a few properties of logarithms. Okay. So the main one when it comes to dealing with logarithms is that if you have b equals a to the x, which is exponential form, then it can be written in logarithmic form, which is log base a of b equals x. So the base of the exponential is the base of the logarithm. What it equals is right beside the base, and then the exponent is what it equals with the log. Or it's read as if b is a to the power of x, then x is the logarithm of b to base a. It's the proper wording. The way I read it is just log base a of b equals x. So we're going to evaluate a few laws, okay? And then you guys will practice evaluating some laws, okay? But this notation right here is very important. It is in your reference booklet. It is. So if you ever forget it, it's there. All right? But we're going to evaluate log base 5 of 125, okay? We're going to do this without a calculator. Easiest way to evaluate any log is to write it in this exponential form. Okay? That's the easiest way to evaluate it. So, to write an exponential form, you're going to have your base, and then your exponent is what this equals. Well, since we don't know what this equals, that's what we're trying to figure out. We'll just set it equal to x. That's going to be our exponent. And then this part goes here. You see how it matches up to the formula? And we all know our powers, right? It was x, 3. Okay? So then the log of base 5 of 125 is equal to 3. Let's take a look at this one. Log base 64 of 4. Since we're trying to solve, we're going to go ahead and set it equal to x. And how can we set this up to solve this? 64 to the x equals 4. Okay? Now this one, you might not be able to recognize it just, right off the gate. Does anyone know that's okay? Then default back to what you guys did for your homework. How can you rewrite 64 so that it has the same base as 4? Or to the cubed, you still have an x there, and that equals 4. Now that the bases are the same, you just set your exponents equal to each other. What's the exponent right here? A 1. So you'll basically have 3x equals 1, and x equals 1/3. Okay? Think about it. If you take the cube root of 64, you get 4. Okay? But if you can't recognize that right off gate, then you can always default back to what we were doing for your homework on last week. Okay? But to evaluate any logarithm, the easiest way is to convert it back into exponential form. That also will be helpful when we're solving logarithmic equations as well. Questions up to this point? Well, let's practice. Whiteboard's out. Whiteboard's out. I want you to evaluate log base 3 of 1 over 81. Okay? Give you 1 minute. -4. Okay, so it's going to be 3 to the x equals 1 over 81. Remember, 81 can be written as 3 to the what? 4. To bring it up so that it's not in the denominator, you make it a negative, and there you go. X equals -4. Put your boards. Here's the next one. Evaluate log base 5 of the square root of 5. It is 1/2. It's going to be 5 to the x equals the square root of 5. Remember, you can rewrite the square root as a power. What power? 1/2. Just like you can rewrite the cube root as the power what? 1 over what? 1/3. And just like you can write this as what? X to the 3/4. Okay, don't forget. Whatever the root is, that's the denominator of your rational exponent. Here's the next one. Okay, you have a log base 5 of 125 to the 1/2. Give you about a minute and a half for this one. It is 3/2. You'll write it as 5 raised to the x equals 125 to the 1/2. Remember the rule. Get the same base. 125 can be written as 5 to the what? 5 to the 3rd. What are you going to do with that 1/2 and that 3? And that's how you get 3/2. Forget about that 1/2. That 1/2 wasn't the exponent. Clear boards. That is a 9, not a cube. It's the font I use. So log base 9 of 1. This one is 0. Yes, because think about it. The only way that we're going to get 1 is if x is the power of 0. Think about it. Anything to the 0 power is 1. That actually is another property of logarithms, so you might want to add that to your notes. Okay? That is a property. Log base a of 1 is 0, so any base, okay, if it's attached to a 1, it's automatically always 0. Okay, that's the only way that you're ever going to get 1 or have a base raised to an exponent. That's the only way you'll ever get 1. Okay? Whiteboards, you got another one. Log base 4 of 4. 30 seconds. 1, yes, 4 to the x equals 4. The only way you're going to get the exact same thing, or actually look at it, bases are the same. Exponent is 1, so x equals 1. That is another property, okay? When you have a base and it equals the same thing, then it's automatically 1. So log base a of a is 1. Now some log expressions are undefined. Look at this one. Log base 3 of negative 27. Okay? How would you write that in exponential form? Dakota, how would you write this in exponential form? You got log base 3 of negative 27. How would you write that in exponential form? Well, I don't want to answer. I want to like set up in the general form. Yeah. Like if I wanted to solve it. So this is how you set it up in exponential form, okay? And you ask yourself, you know, x to what power gives you a negative 27, okay? You can't do it. There's no way, there's no exponent that's ever going to give you a negative number, at least not with a positive base, okay? Yes, you could rewrite this as negative 3 to the 3rd. Yes, you could write that the thing is the bases aren't the same, okay? There's no way that you like bring this negative up to the exponent. You can't do that. Okay? So, if b is negative, then the log base a of b is undefined. Okay? You can never take the log of a negative number. Never take the log of a negative number. Okay? It's another property of logarithms. I want you guys to do this one on your whiteboards. Log base 3 is 0. It is undefined. Think about it. You have 3 to the x equals 0. There's no way, no exponent is ever going to give you 0. So this is undefined. That is another property. Okay? The log base a of 0 is undefined. Undefined. Okay? So you cannot take the log of a negative number and you cannot take the log of 0. Alright? That should kind of give you an idea of what the graph of a logarithmic function looks like. Okay? You can't have any negative values, negative x's, and you can't have 0. Alright? What about this one? Do this one on your whiteboards. 30 seconds. The answer is 5. You have 2 to the x equals 2 to the 5th. It's already in the same base, so x equals 5. You guessed it. Another property. Okay? Log base a of a to the n equals n. Basically the base and the number, I said the big number, cancel each other out. You're just left with the exponent. Okay? There you go. So you got a nice little list of properties here. Now, are all these properties in your reference booklet? Don't know. Somebody check. Okay? Somebody check right now while I'm talking. If they're not in your reference booklet, then yes, you need to know. However, you can always convert a log into exponential form, and then you'll be like, oh, wait, that is 0. Why did I even do that? Type again. It's like, oh, wait, I can't take the, there's no exponent where it give me a negative number. Oh, wait, it's an undefined thing. Why did I even waste my time? Okay, but you do have that option there. Okay? Look at any? It's not? Okay, so none of these properties are there, but as you can see, you can write them in exponential form and then realize that, hey, there you go. All right? Now, we can use the same concept of writing logs in exponential form to even solve problems, okay? So we have a log base 2 of x equals 5. We have to find x. So writing this in exponential form, Megan, how would I write this? Oh. 2 to the what? 5 equals x. Yes. So remember the bases are the same, and then whatever the log equals is the exponent in the exponential form. And that equals x. So what is x? 32. Come on, gotta be quick. Gotta be quick. X equals 32. Alright? So you can use those to exponential form to solve logs. Okay? Whiteboards. Did you guys need more time? Did I go through that? Okay, whiteboards. Give you 1 minute. Not even 30 seconds. 64. 4 to the third equals x. I think I saw that on everybody's board. So then yes, knowing your powers of 4, x equals 64. Clear your boards. Here's another. It is 8. You'll have x squared equals 64. You'll have to take the square root. Now, the one thing I didn't see on anybody's boards was what? The plus or minus 8. Because technically, when you take the square root, it is plus or minus 8. But, can you have the negative? No, you can't. Okay? It is just going to be the positive one. Okay? You can't have, just like how you can't say the log of a negative number, you can't have the log of a negative base. Okay? So, it's only going to be the positive. Okay? Here's the next one. 30 seconds. It is 1 over 32 because you'll have 2 to the negative 5 equals x. You can't have any negative exponents, so you flip it to make it positive, and that's how you get 1 over 32. Awesome. Clear your boards. Here's the next one.